Unit 4 is on quality management systems and practices. This unit talks about the systems and practices which are used in the apparel quality industries, for the apparel quality in the industries. The unit objectives are, by the end of this unit, students will be able to review the various statistical tools and their usage, examine quality management concepts, discuss the concept of costs of quality and quality management grid, explain managing quality in decentralized manufacturing, define the concept of benchmarking. Tools of quality control. In this module, we will talk about statistical quality control, statistical quality control, wherein we take the help of statistical methods. We take the help of statistical methods so that we can maintain the quality of products as well as services. Statistical quality control can be divided into three broad categories. The first category being descriptive statistics. What is descriptive statistics? Descriptive statistics is the usage of statistics like mean, median, mode, range, and the measure of the distribution of data. What is mean? Mean is basically the average of the given data. Let's say we have 4 values, so the mean will be the average of these 4 values. The next one is median and mode. They also are a part of different basic statistics, wherein median is the middle value and mode is the most common value. When we talk about range, we talk about minimum as well as maximum value of a particular variable. And when we talk about distribution of data, we have normally distributed data, something like this, wherein all the values they lie across the average or the mean of the data. The data can be skewed also, something like this or something like this. So this is what we known by descriptive statistics, where we use these concepts. The second broad category is statistical process control, that is also known as SPC, statistical process control. It involves when you inspect a random sample of the output from a process and decide whether the process is producing products with characteristics that are required. The third basic broad category of statistical quality control is acceptance sampling. Acceptance sampling, on the basis of acceptance sampling, we can decide whether we need to accept that batch of goods or we need to reject that batch of goods. Under this, we are going to study statistical quality control, that refers to the use of statistical methods in the monitoring and maintaining of the quality of products and services. It can be divided into three broad categories. The first one being descriptive statistics. Descriptive statistics is used to describe quality characteristics and relationships. These include statistics such as the mean, standard deviation, the range, and a measure of the distribution of data. The second broad category is statistical process control under statistical quality control. Statistical process control involves inspecting a random sample of the output from a process and deciding whether the process is producing products with characteristics that fall within a predetermined range. Statistical process control answers the question of whether the process is functioning properly or not. The third category is acceptance sampling under statistical quality control. Acceptance sampling is the process of randomly inspecting a sample of goods and deciding whether to accept the entire lot based on the results. Acceptance sampling determines whether a batch of goods should be accepted or rejected. There are 7 tools of quality control named as check sheets, histograms, scatter diagrams, Pareto charts, flowcharts, cause and effect diagrams, control charts. We'll go through all these 7 tools of quality control one by one. These quality tools are quite generic and can be applied to any condition across all domains. These tools can provide much information about problems in the organization, assisting to derive solutions for the same. There are 7 tools of quality control. These are named as check sheets, histogram, scatter diagram, Pareto charts, flowcharts, cause and effect diagram, and control charts. These quality tools are generic. When we talk about generic, that goes to say that they can be applied irrespective of any particular criteria, and they can be applied to any condition across any domains. These tools help us in finding out the problems, working out, analyzing the same, and providing the solutions of these problems. The first tool what we are going to talk about are check sheets. Check sheets are basically, they are required to collect the data, and it can be used for many purposes. Let's say if we want to calculate the defects in the manufacturing area, so we will talk about broken stitches. We have found this as a defect and we have inspected, let's say, 30 pieces. So the number of pieces that will have broken stitches will be marked as something like this. The next defect being run stitch. So one piece of broken stitch defect we received and one piece of run stitch we received. So like this we are going to mark it in terms of number. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, all the defects coming to 30 pieces, 30 checked pieces in total. The next quality tool is histogram. Histogram, they're also known as bar charts or bar graphs. This is a graphical depiction and they show us frequency distribution and how much different each value is there in a data. Something like this. Wherein some people are disagreeing, let's say 5, others are agreeing to a specific situation, let's say 7. Mostly people disagree, let's say 10 situation, 10 in number, and so on. Scatter diagram. Scatter diagram is another tool for statistical quality control. These are simplest and the most useful diagrams, and they can tell us the relationship between two factors. In this case, when we plot a graph, if the slope is going up, then the two factors have positive correlation, but in case the slope is going down, then we'll have a negative correlation. When we talk about positive correlation, it goes to say with the increase or with the effect in X factor, the Y factor also changes positively. If there is no pattern, then there is no correlation between the two factors. Let's say time and water. So there are two factors wherein there is absolutely no correlation. The graphs, the pairs of numerical data, there is one variable is plotted on each axis. Next is our Pareto chart. Next tool what we are going to talk about is Pareto chart, which is nothing but a histogram wherein the events, they are arranged in a descending order. Something like this. So the events are arranged in a descending order. Next are our flowcharts. Flowcharts talk about generally the sequential events or activities, or they can also talk about the activities in parallel. Let's say shirt back, shirt front. So it will have its own activities, but these activities can run parallelly to each other. Flowcharts are used to describe processes that are complex. They're also called process mapping and analysis. There are certain there's another tool that is there, that is cause and effect diagram. Cause and effect diagram. Now cause and effect diagram were started or were Dr. Ishikawa had given the concept of these diagrams. So they're also known as Ishikawa diagrams or fishbone diagram. Through these diagrams, we can go to the root cause of a certain problem. And we can go to the sub causes. Let's say this is the effect and these are the causes. So we can go to the sub causes also with the help of fishbone diagrams, Ishikawa diagrams, or cause and effect diagrams. Then we have run charts and control charts. Next slide is off. Next slide is giving a graphical representation wherein we have an upper control limit and a lower control limit. In between, we have the run charts. Now, run charts tell us how a problem is, what is the frequency of that problems, and how do we control with the help of upper control limit and lower control limit. The first tool is check sheet. Check sheets are structured, prepared forms for collecting and analyzing data. It's a generic tool that can be adapted for a wide variety of purposes. The second tool is histogram. It is also known as bar chart or a bar graph. It is a graphical depiction of a number of occurrences of an event. This is a most commonly used graph for showing frequency distributions or how often each different value in a set of data occurs. The next tool what we study under statistical quality control is scatter diagram. This is the simplest and most useful tool. It's useful in finding relation between two factors. The important point to note is if the slope is going up, then it has a positive correlation. If the slope is going down, then there is negative correlation. If there is no pattern, then there is no correlation. Graphs pairs of numerical data with one variable on each axis. Next tool is Pareto Charts. It is a histogram where a number of occurrences of an event are arranged in descending order, shows on a bar graph which factors are more significant. Next tool is Flowchart. The tool maps out a sequence of events that take place sequentially or in parallel. The flow chart can be used to understand a complex process in order to find the relationships and dependencies between events. Flow charts can be used for any field to illustrate complex processes in a simple way. These are also called process mapping and analysis. There is an example of flow chart given in the presentation. The next our tool, statistical tool in apparel quality management is cause and effect diagram. These are also called fishbone diagrams because of their shape and are also known as Ishikawa diagrams based on the famous management guru Ishikawa. The cause and effect diagram helps in identifying root causes of the quality failure. It identifies many possible causes for an effect or problem and sort ideas into useful categories. Next are run charts and control charts. A control chart is a graph that is used to study how a process changes over time. Comparing current data to historical control limits leads to conclusions about whether the process variation is consistent, that is in control, or is unpredictable, that is out of control and affected by special causes of variation. Graphs used to study how a process changes over time. So these are the graphs that are used to study how a process changes over time. The run chart is a measurement against progression of time. Control chart, when you add upper control limit and lower control limit to the run chart. In addition to 7 basic tools of quality control that we just studied, we have 7 new management and planning tools which we are going to go one by one. Now these are affinity diagrams, relations diagrams, tree diagram, matrix diagram, arrow diagram, and PDPC, that is process decision. List of tools, we have arrow diagram and process decision program chart. We'll start with these tools one by one, starting with affinity diagram. Affinity diagrams can organize large amount of disorganized data so that we can analyze it properly and we can derive our conclusions from the same. It is used when there are many facts and ideas and the issue is very large and complex. Now, affinity diagrams, they are graphically represented as nested diagrams. Nested diagrams, affinity diagrams, as we were saying, these diagrams can also be represented as nested squares and they represent different levels of the problem. We have a top level boxes then we segregate or then we finalize or then we streamline them into second level, then we streamline into third level and finally the single point. Next is our relations diagram. Relations diagram. Relations diagram. Now, relations diagrams also show cause and effect relationships and they are used for persistent and complex problems that have apparently no solution. There is a problem what we can analyze over here. There's a case study where we are going to find out why are the students so out of control. Now this is the situation that needs to be analyzed. So maybe the problem can be lack of information, regarding the school, regarding the staff, regarding the students, or whatever the information that is required. The problem can also be lack of training. Lack of training. There can be many factors to this. So the major factor that was found over here was different expectations in different classrooms. When we talk about relations diagram, the major, in the case of major cause, the arrows point towards it or away from the reason. The major cause found in this situation was lack of information, and which has got around 7 causes to the different factors. Next is a tree diagram. Tree diagram is also known as systematic diagram, tree analysis, analytical tree, and hierarchy diagram. The tree diagram has, the one item has branches where it can be branched into 2 or more, depending upon that it should look like a tree. There are various categories in which the factors are broken down into, so that we can go to the finer levels of detailing. Now, why do we use tree diagram? When we have broad generalities that need to be moved or that need to be studied under specific details, so that we can devise logical steps to achieve the given objective. Also, when we analyze the processes in detail. This is the structure of a tree diagram, wherein we go to the finer and finer details of the categories. Next is our prioritization matrix. Prioritization matrix, which helps us in prioritizing items so that we can give them a weighted criteria. Weighted criteria. This is again a statistical concept where we give different weights to different factors. So prioritization matrix looks something like this. So it looks something like this, and we prioritize the factors or the data, whatever we have the availability. Next kind of statistical tools are matrix diagrams. Matrix diagrams are very helpful to show the relationship between 2, 3 or even 4 groups of information, and they can give the information regarding the roles played by these groups. There are different types of matrix diagram. So one is T-shaped matrix. something like this. So wherein we have these factors and we can draw a relationship between these two and these two. There is no interrelationship between these factors in general. So in one diagram, we can describe the relationships between three variables. The second kind of matrix diagram is Y-shaped matrix. Y-shaped matrix can again give the information about three groups. And we can draw the relationship between two variables. Each group is related to the other two in a circular fashion in this case. There is next type of matrix diagram is known as C-shaped matrix, wherein we build the relationships in three dimensions. It is something like this. So where we have a 3D relationship between different factors. Next kind of matrix is X-shaped matrix, wherein we can give a relationship between four group of items. So we can give a relationship between this. We can define between the relationships between four variables in a single diagram. Next is our L-shaped matrix. L-shaped matrix, it relates to two group of items to each other. L-shaped. So wherein we can give the relationship between two items in a single diagram. Next is roof-shaped matrix. Roof-shaped matrix, in this case, one group of items is related to themselves. It is usually used along with L or T-shaped matrix. So something like this. So it gives a relationship between the variables themselves. So 1 and 2 will have a relationship something like this. This was all about matrix diagrams. The next one statistical tool that we use are arrow diagrams. Arrow diagrams, they are also known as activity network diagrams, activity charts, node diagrams, or critical path method. Arrow diagrams are used to plan the appropriate sequence or schedule for a given set of tasks. The diagrams help in determining the critical path or the longest sequence of tasks. Next, the last tool what we have known as the new management tool is known as Process Decision Program Chart, also known as PDPC. It is an extension of tree diagrams wherein we are trying to use different shaped boxes so that we can highlight the risks and identify the possible countermeasures. We have the usage of clouds also that indicate the uncertain nature. Something like this, wherein we have different shapes of boxes trying to organize the data, and we have clouds also wherein we are trying to say the uncertain nature of that particular. There are 7 new management and planning tools in addition to the old quality management tools. The 7 management planning tools listed in an order that moves from abstract analysis to detailed planning are Affinity Diagram. It organizes a large number of ideas into their natural relationships. Second tool is Relations Diagram, shows cause and effect relationships and helps you analyze the natural links between different aspects of a complex situation. The third tool is Tree Diagram. It breaks down broad categories into finer and finer levels of detail, helps you move your thinking step by step from generalities to specifics. The next tool under the list of tools is Matrix Diagram, that shows the relationship between 2, 3 or 4 groups of information and can give information about the relationship such as its strength, the roles played by various individuals or measurements. Next management planning tool is Arrow Diagram, that shows the required order of tasks in a project or process, the best schedule for the entire project and potential scheduling and resource problems and their solutions. Next is Process Decision Program Chart, also known as PDPC. It systematically identifies what might go wrong in a plan under development. Let's go through all these tools one by one in details. The first one is Affinity Diagram. Affinity diagrams are a special kind of brainstorming tool that organizes large amounts of disorganized data and information into groupings based on natural relationships. An affinity diagram is used when you are confronted with many facts or ideas in apparent chaos. Issues seem too large and complex to grasp. Affinity diagram is typically represented graphically as nested squared concept which have smaller and smaller subgroupings of concepts. Next tool is relations diagram. The relations diagram shows cause and effect relationships. A relations diagram is used for persistent, complex problems that have no apparent solutions. The key driver process reveals which cause to address first with a solution. To use the relations diagram, the team looks at each cause and determines which causes are the strongest drivers. Each cause is measured against other causes individually. The stronger cause is depicted with the arrow pointing away from the cause. There is an example of relations diagram. This example was completed with a team of teachers and administrators who were exploring why the high school had such unruly students. The problem existed for years, surviving several different administrations and staff changes. Each of the causes below was identified and grouped together through a think, ink, link activity. As was told earlier, in the relations diagram, the stronger cause is depicted with the arrow pointing away from the cause. In this example, lack of information and training for staff and students on common school policies is the number one driver, followed by office staff not communicating expectations and roles to teachers. Using this tool will help teams know what action they need to take first to solve the problem they are facing. Next is tree diagram. It is also called systematic diagram, tree analysis, analytical tree, hierarchy diagram. The tree diagram starts with one item that branches into two or more, each of which branch into two or more, and so on. It looks like a tree with trunk and multiple branches. It is used to break down broad categories into finer levels of detail. When to use a tree diagram? When an issue is known or being addressed in broad generalities, and you must move to specific details, such as when developing logical steps to achieve an objective. When developing actions, to carry out a solution or other plan. We use tree diagram when we analyze processes in detail. When we probe for the root cause of a problem, when evaluating implementation issues for several potential solutions. After an affinity diagram or relations diagram has uncovered key issues, we use tree diagram as a communication tool to explain details to others. The next tool is Prioritization Matrix. This tool is used to prioritize items and describe them in terms of weighted criteria. It uses a combination of tree and matrix diagramming techniques to do a pairwise evaluation of items and to narrow down options to the most desired or most effective. Popular applications for the prioritization matrix include return on investment, also known as ROI, or cost benefit analysis, that is, investment versus return. Time management matrix, that is, urgency versus importance, etc. The next tool under study is matrix diagram. It shows the relationship between 2, 3 or 4 groups of information and can give information about the relationship such as its strength, the roles played by various individuals or measurements. The types of matrix diagram include T-shaped matrix. It relates 3 groups of items. Groups B and C are each related to A. Groups B and C are not related to each other. Then we have Y-shaped matrix that relates three groups of items. Each group is related to the other two in a circular fashion. C-shaped matrix relates three groups of items or together simultaneously in 3D. X-shaped matrix relates four groups of items. Each group is related to two others in a circular fashion. L-shaped matrix relates two groups of items to each other or one group to itself. Roof-shaped matrix relates one group of items to itself. It is usually used along with an L or T-shaped matrix. Arrow diagram. They are also called activity network diagram, network diagram, activity chart, node diagram, CPM, that is critical path method, CPM chart or critical path method. Arrow diagram is used to plan the appropriate sequence or schedule for a set of tasks and related subtasks. It is used when subtasks must occur in parallel. The diagram helps in determining the critical path, longest sequence of tasks. The purpose is to help people sequentially define, organize and manage a complex set of activities. Process decision program chart. Process decision program chart is a useful way of planning to break down tasks into a hierarchy using a tree diagram. The PDPC extends the tree diagram a couple of levels to identify risks and countermeasures for the bottom level tasks. Different shaped boxes are used to highlight risks and identify possible countermeasures that are often shown as clouds to indicate their uncertain nature. Quality management systems. In this module, we will talk about various quality management systems and we will talk about the most common used tools. List of the commonly used tools consist of benchmarking. It is a method of comparing companies' practices with the practices of best in class organization in the areas of quality, productivity, human resources and cost, etc. Six Sigma. Six Sigma is a business strategy to achieve excellence by applying different statistical, total quality management and project management tools. Lean manufacturing. Lean manufacturing is a way of manufacturing that increases speed and reduces unnecessary waste. Lean Six Sigma. Lean Six Sigma is combination of Six Sigma and lean manufacturing concept to reduce errors and increase productivity side by side. Quality management system. Quality management system ISO 9000 is set of standards for quality management for any organization by International Organization for Standardization, also known as ISO. Kaizen. It is a Japanese tool for small but incremental changes in daily business life. Next, from the list of the commonly used tools is 5S. 5S is methodology for improvement in daily and business life in 5 steps. Quality circles. Quality circles is a group of people who identify problems and give their solution for improvement in daily life and business. The first tool is Kaizen. The first quality management system is Kaizen, which is a Japanese word. Kaizen can be segregated into two words, Kai that means continuous and Zen that means improvement. In the gist of Kaizen is that it preaches or it tells about continuous improvement that is slow, incremental but constant. We'll discuss about the key features of Kaizen. The philosophy behind Kaizen is that when we do small improvements, we can avoid major capital investment. The ideas for Kaizen, they come from the workforce who is already there in the organization, and therefore the cost on research and development and consultancy can be decreased. As there are workers who are already working in the organization are giving the suggestions or improvements, they cannot be very much different from each other. And therefore, because they understand the organization very well, so it becomes easier to implement Kaizen. Now, Kaizen also helps encourage workers where they take the responsibility of their work, and it reinforces the concept of team working. There are some problems which are associated with Kaizen. First of all, the main one is the change in the attitude. In order to implement this concept, it becomes very important to change the attitude of the employees, which is a huge task. The workers may not be ready to go for a change. As we say, change becomes very difficult when everybody is in their comfort zone. The management may not be ready to implement the initiatives because they are looking for quick profit. Another major problem can be there can be aversion to the long-term concept, as it is not a one day or a short-term improvement strategy. It gives its benefits only in the long term, so it becomes sometimes the management and the employees may not be accepting the long-term concept. The next quality management system is quality circles. Quality circles is a participatory management technique wherein the employees are participating in the management of the organization. Circles, in this case, quality circles are small natural work teams, people who are naturally together, who meet at different intervals or regular intervals so that they can discuss the problems of quality and they can devise the requisite solutions. They have an autonomous character. The quality circles, they have an autonomous character and they are usually small and they are led by some senior person. There are many advantages of quality circles. There is a stronger identification with the organization and there is a personal commitment that is increased. Quality circles also connect the existing informal groups with the management. They contribute to the qualification of employees and lead to discussions and communications in-house to improve the working environment. Now, quality circles can be done into 3 stages. The one being phase, the second being action, and the third being disruption forces. So there are 3 you can say the quality circle, the entire process can be categorized into 3 phases. The initial phase is startup phase. The initial phase is startup phase where the action taken is publicize. We publicize what we are trying to do. When we publicize what we are trying to do, there may be low volunteer count. The disruption forces can be low volunteer count. In the same startup phase, we can also have another action, that is invite volunteers. Invite volunteers. The disruption forces over here can be inadequate knowledge and apprehension of these volunteers. The second phase for quality circles, can be initial problem solving. Initial problem solving. The actions that can be taken here are to realize the problems, wherein the disruption forces can be inadequate process knowledge. Without having process knowledge, it is difficult to act on a problem. The second action under initial problem solving can be try to find solutions. try to find solutions where the disruption forces can be disagreement on problems. The third phase for quality circles is approval of initial suggestion. Approval of initial suggestion, wherein the action can be presentation of initial suggestion to management. Now, the disruption forces which can hinder the successful implementation of quality circles can be poor presentation, resistance from staff, or poor quality of solutions due to the lack of knowledge. So this is the way how we implement the different phases of quality circles. We do have the disruption forces also. Students, the next quality management system we are going to talk about is Lien. Now, Lien is also a very popular concept. We'll talk about the definition first. It is a systematic approach in identifying and eliminating waste. Eliminating waste or non-value added activities. Non-value added activities through continuous improvement. Continuous improvement by making products through improved speed and flexibility. Improved speed and flexibility with best quality and lowest cost. As we see, we have listed down all the major words which are used in the definition of Lien. Eliminating waste. So we have to cut down all the activities that are not adding, that are considered as a waste in the process of the organization. So what are these activities which are considered as waste? That we'll see in the next slides. The second important word is non-value added activities. The activities which are not adding any kind of value to the final product need to be cut down. The next important word is continuous improvement. Lien focuses on continuous incremental improvement so that we can have improved speed. Our speed of producing goods may be improved, and we are flexible enough to produce different types of goods. Best quality and lowest cost. So, we do all these things, we try to find out all the processes, or we do the process improvement so that we can have the best quality at the lowest cost. We were talking about waste. We talked about waste in our last slide. Waste is also known as muda. A brief on what are the different forms of waste. There are 7 forms of waste. One is correction. alterations, reworks, repairs, corrections, they consume time as well as money. So this is one of the kinds of waste which we need to eliminate. Transportation. Transportation also is a non-value added activity wherein we are adding onto the time and money spent on the products. Waiting. When we wait for work, we are again, it is a non-value added activity in terms of time and money. When we overproduce, overproduction is again another form of waste. Overprocessing, when few of the processes are not required but they are there in the final process, that is overprocessing. Motion of the products is also another form of waste. And inventory, the build up stock, this is also another form of waste which needs to be eliminated to have the products at the most economical, best quality products in our organization. Now there are 4 rules to Lean, that is Lean starts with rules but not tools. There are 4 rules to Lean. We need to structure each and every activity. There should be a clear connection of customer and supplier. Every flow should be simplified. And experimentation, we need to do experimentation at the lowest level in order to improve so that we can reach at the ideal state. The next quality management system is known as 5S. The 5S are housekeeping standards. The philosophy behind being when the atmosphere is clean, organized, safe, and efficient, the workplace is productive for everyone. 5S stands for 5 S's in Japanese. They are known as Sairi, Saito, Saiso, Saiketsu, and Shitsuke. These 5S or these 5 Japanese words, they have different meanings, overall coming down to the housekeeping of the organization. They stand for SOT, that is, everything at the workplace should be identified, what is needed to be kept in proximity and what is not needed needs to be discarded. Straighten, organizing the way the things are put away with efficiency, quality and safety in mind. Sweep, we need to sweep, scrub and cleaning of the building, machines, fixtures, tools, everything so that the workplace is neat and tidy. Sanitize, we need to ensure that each workplace is there for safety. Safety is the utmost concern, so the workplace needs to be safe. Sustain, the routines and procedures for maintaining and improving the 4 S's what we just described by incorporating visual management tools. So sustain is the one that we need to continuously organize the first 4 tools of 5S. Students, now we are going to talk about the next quality management system, that is Six Sigma. Now Six Sigma has gained a lot of popularity in the recent years. Just a little bit about its origin. The concept was originated by in Motorola when they started having failures, and the concept became so popular that now there are major organizations who are following Six Sigma. Sigma over here stands for Greek alphabet. It generally represents the degree of variation in the standardized products. It is a statistical measurement unit which talks about the variations in the products we have from the standard. Now when we talk about Six Sigma, it takes the help of statistical tools as well as non-statistical tools like team management, project management and leadership tools, apart from the approach of DMAC. Now Six Sigma means the quality level of the product is quite high. There's a lot of performance, the processes are giving a lot of performance, and the products are reliable for the customer. Six Sigma can be represented in statistical terms as DPMO. DPMO, that means defects per million opportunities. Now these defects per million opportunities, they are translated into a sigma number. Higher the sigma, better the quality of the product. Now, what is the relationship between sigma levels and DPMO? When we have sigma level 2, sigma level 2, the defects per million opportunities are roughly 3 lakhs. When we have Six Sigma level 3, the defects per million opportunities are 67,000. When we have Sigma level 4, the defects per million opportunities are 6,000. When we have Sigma level 5, the defects per million opportunities is 250. And when we have Sigma level 6, the defects per million opportunities goes to 3.4. So we can see the difference between Sigma level 2 and Sigma level 6. It is up to the organization to find out at what Sigma level they are working. In order to go for Sigma level 6, one needs to understand the process, to see the gaps wherein the desired results are not being achieved and act on that. It is a universal quality metric and it can be adopted irrespective of product complexity or dissimilarities between different products. As we said, higher the sigma level, fewer are the number of defects per unit of product. The products which are there in a which are produced at a 6 sigma level of quality, we can see are virtually defect free. Now 6 sigma level utilizes the approach of DMAC. DMAC stands for defining of the problem, measuring, analyzing, improving, and then controlling. So DMAC cycle is a very important approach of Six Sigma where it defines, measures, analyzes, improves, and controls the process. Next quality management system is FMEA. FMEA, Failure Modes and Effects Analysis. Failure Modes and Effects Analysis. In this case, each item in a system is examined and it is seen that how that item can fail and how will that failure affect the system. There's an acronym of FMECA here, that is Failure Modes and Effects and Criticality Analysis. Now the benefits of FMEA are, there are improvements in safety, quality and reliability. The other potential benefits are increase of company image, satisfaction of the user, the cutting down of the developmental costs and presence of a record that is historical. The next quality management system is QFD, that is Quality Function Deployment. Quality Function Deployment, which is also referred as Matrix Product Planning, Decision Matrices, and Customer Driven Engineering. The QFND methodology, it focuses on the most important product or service attributes or qualities. Now QFND can be described into by explaining various houses of quality which are in customer domain, functional domain, design domain and process domain. There's a house of quality where voice of the customer is given the priority, and then you have interaction matrix, relationship matrix and so on. Now the basic steps of QFND are to identification of the customer needs, translation of the customer needs into quality elements, and deploying and usage of important quality elements so as to achieve the desired quality. Now we will deal with all these quality management concepts one by one. The first one being Kaizen. This can be broken down into two words where K means continuous, Zen means improvement or wisdom. The Kaizen management philosophy is defined as making continuous improvement slow, incremental but constant. Key features of Kaizen. Small improvements are less likely to require major capital investment. The ideas come from the talents of the existing workforce, thereby reducing the R&D, that is research and development, consultancy cost, as the ideas come from the workers themselves. They are less likely to be radically different and therefore easier to implement. It helps encourage workers to take ownership for their work and can help reinforce team working. The problems that can be faced during implementation of Kaizen can be huge attitudinal change. Hence, in some cultures, still not acceptable. Second problem being hesitation of workers, that is no readiness. Third one being no readiness of management, orientation on quick profit, aversion to the long term concepts, finding of quick and immediate solutions. The next quality system that we will talk in detail is about quality circles. It is a participatory management technique that enlists the help of employees in solving problems related to their own jobs. Circles are formed of employees working together in an operation who meet at intervals to discuss problems of quality and to devise solutions for improvements. Natural work team, using its observations about the work process to identify opportunities for improvement. Quality circles have an autonomous character, are usually small and are led by a supervisor or a senior worker. Quality circles advantages. It promotes a stronger identification with the enterprise and increased personal responsibility for the job on the part of the employees. Quality circles connect the existing informal groups with the management. Quality circles contribute to the qualification of employees, lead to in-house dialogue and generally improve the working environment. Quality circles, implementation of quality circles in an organization. There are 3 stages of phase, action and disruption forces. Phase 1 is the startup phase. The action to be taken here is publicize, and invite volunteers. The disruption forces can be low volunteer count, inadequate knowledge and apprehension. the phase of initial problem solving. The actions can be taken are to realize problems, try to find solutions. The disruption forces are inadequate process knowledge and disagreement on problems. Next phase is approval of initial suggestion. Action required is presentation of initial suggestion to management. The disruption forces can be poor presentation, resistance from staff, or poor quality of solutions due to lack of knowledge. Next quality management system we are going to talk about is Lien. What is Lien? It is a systematic approach in identifying and eliminating waste or non-value added activities through continual improvement by making products through improved speed and flexibility with best quality and lowest cost. There are 7 forms of waste, namely correction, transportation, waiting, overproduction, overprocessing, motion, and inventory. Lien starts with rules, not tools. The 4 rules of Lien are: structure every activity, clearly connect each customer and supplier, specify and simplify every flow, improve through experimentation at the lowest level possible towards the ideal state. Next quality management system is the 5S housekeeping standards. The aim of 5S is to create an atmosphere to keep a clean, organized, safe and efficient workplace for everyone. The 5S stands for Japanese words seri, seton, seso, seketsu and shitsuke. It's a conventional approach towards maintaining and improving the workplace. The 5S housekeeping standards can be termed as sort, sanitize, sweep, straighten and sustain. When you sort, we examine everything at the workplace and identify what is needed and what can be discarded. Straighten, organizing the way things are put away with efficiency, quality and safety in mind. Sweep, sweeping, scrubbing and cleaning of the building, machines, fixtures and tools so that all areas of the workplace are neat and tidy. Sanitize, also termed as safety, ensuring that each workplace is properly designed for safety. Sustain, to standardize, establishing routines and procedures for maintaining and improving on the first 4 S's, incorporating visual management tools. The next quality management system is about 6 Sigma, origin. Sigma is a letter in the Greek alphabet. It is a statistical measurement unit. What does 6 Sigma level mean? Quality level of product, process performance, reliability for customer. DPMO means defects per million opportunities. This is translated into a sigma number. Relation between sigma levels and DPMO. Sigma level 2 indicates DPMO of 3 lakhs. Sigma level 3 indicates DPMO of 67,000. Sigma level 4 indicates 6,000 defects per million opportunities. Sigma level 5 indicates 250 defects per million opportunities. Sigma level 6 indicates 3 defects per million opportunities. The higher the sigma level, the better. 6 sigma. Universal quality metric that can be applied regardless of the product complexity or dissimilarities between different products. Higher the sigma level, fewer the number of defects per unit of product. Products produced at 6 sigma level of quality operate virtually defect free. Higher sigma values indicate better product and lower values represent less desirable products. Higher sigma value indicate better product. DMAC cycle of 6 sigma. D stands for define, customers, value, problem statement, define, scope, timeline, team, primary or secondary, current value stream map, voice of customer, measure, assess specification or demand, measurement capability, correct the measurement system, process map, measure OVs and Qs. Analyze root cause, FMEA, graphical analysis, ANOVA, future value stream map, improve, optimize KPOVs and test the KPIVs. Redesign process 5S, cell design, visual controls, value stream plan. Control through document process, mistake proof, analyze change in matrix, value stream review, prepare final report. Next quality management system tool is, what is an FMEA? It is a procedure that examines each item in a system, considers how that item can fail, and then determines how that failure will affect the system. The acronyms being FMEA, Failure Modes and Effects Analysis, FMECA, Failure Modes and Effects and Criticality Analysis. Benefits of FMEA. There are improvements in safety, quality, reliability. Other potential benefits being company image, user satisfaction, lower development costs, presence of a historical record. FMEA flow chart. Assign a label to each process or system component. List the function of each component. List potential failure modes. Describe effects of the failures. Determine failure severity. Determine probability of failure. Determine detection rate of failure. Assign RPN. Take action to reduce the highest risk. Each component must be labeled. Each component must be labeled so none of them will be overlooked. Develop a block diagram that shows the components or steps and indicate how they are related. List the failures that may occur with each function. This is the failure mode. Determine what the ultimate effect of the failure will be. Examples are product or process fails to function, the user is injured, physical defects occur, color is wrong, etc. Anything that would cause the product or process to be undesirable to the user or consumer. Estimate which failure would be the most severe. Failures that could cause human injury would be the most severe. Rank these 1 through 10, 1 being least severe, 10 being most severe. Weight the probability of the occurrence on a scale of 1 to 10. 1 being least likely and 10 being most likely to occur. Based on the current controls of the company, determine the likelihood that a failure would be detected. Rank them from 1 to 10, 1 being least likely to detect, 10 being most likely to detect. Decide which risks take the highest priority. This can be determined from the previous factors. A combination of the severity, probability, and the likelihood of detection should determine which risks would take priority. Assign responsibility of the highest risk and set a completion date. Update the FMEA as action is taken. Once a failure mode has been neutralized, determine the next highest risk. Also, an update will be needed if there is a change in the product or service that could produce new failure modes. The risks are assigned a risk priority number. This is equal to severity rank, probability rank, and detection rank. The next quality management system is quality function deployment. Quality function deployment is also referred as matrix product planning, decision matrices, and customer driven engineering. The QFND methodology focuses on the most important product or service attributes or qualities. Quality function deployment is the deployment of customer driven qualities to the responsible functions of an organization. Classically, there are 4 houses of quality in QFD. QFD1 pertains to customer domain. QFD2 pertains to functional domain. QFD3 indicates design domain. QFD4 indicates process domain. The House of Quality provides a requirements planning capability, a tool for graphic and integrated thinking, a means to capture and preserve the engineering thought process, a means to communicate the thought process to new members of the QFD team, a means to inform management regarding inconsistencies between requirements, risks, and needs of the customer. 3 basic steps of QFND are: identify the important customer needs, translate customer needs into quality elements, deploy the important quality elements for achieving quality. QFND principle: process customer needs from voice of customer into demanded qualities, translate customers' demanded qualities into substitute characteristics of product. Display the relationship between demanded qualities and substitute characteristics. Deploying the voice of customer. Students, in this presentation we had learned about different quality management systems which can be used in the apparel manufacturing industry. We talked about Kaizen, that is a Japanese quality management system. We talked about Six Sigma, which is a very popular approach now. We talked about lean manufacturing. We also talked about 5S, that are housekeeping standards. We talked about quality function deployment and failure FMEA. So these are the quality management systems which are used in apparel quality management in order to have continual improvement. Benchmarking. Benchmarking, the continuous process of measuring products, services, and practices against the company's toughest competitors or those companies renowned as industry leaders. Benchmarking is a method of establishing performance goals and quality improvement projects based on industry best practices. Benchmarking objectives: to energize and motivate its people, an organization must establish that there is a need for change. Identify what should be changed. Create a picture of how the organization should look after the change. Advantage of benchmarking: learn from others' experience and practices, allows examination of present processes, aids change and improvement. Competitive advantage: overall industry improvement. The 10-step benchmarking process. Phase 1 is of planning. Decide what to benchmark. Identify whom to benchmark. Plan the investigation and conduct it. Phase 2, analysis. Full understanding of internal business processes before comparing them to external organizations. Examine the best practices of other organizations. Measure the gap. Project the future performance levels. Phase 3, integration. Redefine goals and incorporate them into the planning process. Communicate benchmarking findings and gain acceptance from upper management. Revise performance goals. Goals that reflect projected improvement are necessary. On the basis of the benchmarking findings, the targets and strategies should be integrated into business plans and operational reviews and updated as needed. Phase 4 Action. Best practices are implemented and periodically recalibrated as needed. Develop and implement action plans. Monitor progress. Recalibrate the benchmarks. The formal 10-step benchmarking process. Benchmarking process phases: identify benchmark subject, identify benchmark partner, determine data collection method, collect data, determine competitive gap, project future performance, communicate results, establish functional goals, develop action plans, implement plans and monitor results, recalibrate benchmarks. Phase 5 Maturity. Phase 5 Maturity. Maturity is achieved when best practices are incorporated in all business processes. When benchmarking becomes a standard part of guiding work, and when performance levels are continually improving toward a leadership position. Step 1. What to benchmark? Development of a clear mission statement detailing the reason for the organization's existence, including key outputs expected by its customers and critical to fulfilling the mission successfully. Step 2. Whom to benchmark? Internal benchmarking. Within every organization exists another department that may be performing identical or similar work to that of the benchmarking team. Competitive benchmarking. Benchmarking competitors is an essential part of any external comparison. Functional benchmarking and world-class leaders partnering. Types of benchmarking: product benchmarking, for example, cars, washing machines, sewing machines. Process benchmarking, for example, marketing, logistics, employee training. Strategy benchmarking, for example, core competencies, company philosophy. Internal benchmarking, between factories in same branch, between departments, between working groups. External benchmarking, referring to competition and branches independent of branches. Step 3A is to collect data: internal, external, original. Step 3B, conduct the site visit. Step 4, analyze the performance gap. Step 5, project performance levels. Step 6, communicate findings. Step 7, establish functional goals. Step 8, develop action plan. Step 9, implement plan and monitor results. Step 10, recalibrate benchmarks. Conclusion: benchmarking represents a versatile process management tool that helps organizations identify and understand what constitutes best operating practices. A flexible set of benchmarks reflects full process or system capabilities. Performance indicators may include dimensions such as cost, productivity, cycle time, yields, error rates, waste and turnover. Costs of quality. This module talks about the various costs that are associated with quality. Now, costs of poor quality are the costs that are incurred in finding and correcting the defective work which is found in factories. The cost of poor quality can be categorized into cost of non-conformities cost of non-conformities, that is, the products which are not conforming to the specifications, the cost that is incurred there in their repairs, maybe rejections or alterations. The second categorization of cost of poor quality is cost of inefficient processes. So, inefficient processes are the ones where the processes are not able to give good output and they are inefficient in terms of producing a quality good. The third categorization in cost of poor quality is cost of lost opportunities for sales revenue. The opportunities that we lose and we are not able to earn any kind of revenue on that, that is the third categorization of cost of poor quality. Now, we would like to talk about the objectives of evaluating quality and costs. Objectives for evaluating quality and costs. Why do we need to evaluate the quality and its costs? This is to quantify the size of the quality problem so that it leads an impact to upper management. If the quality problem is quite sizable, so it will have an impact on the upper management. To identify major opportunities for reduction in cost of poor quality. So we have to find out the opportunities wherein we can increase the quality or where we can reduce the costs that are associated with poor quality. Also to identify opportunities wherever we can reduce the customer dissatisfaction and the threats that are associated to sales revenue with respect to those opportunities. The quality and costs also provide a mean of measuring the result of quality improvement activities. And the last is that we need to align the quality goals with the organization goals for the overall growth. There are various categories of quality costs which we are going to talk about now. The first one being prevention costs. Prevention costs are the one wherein the costs are incurred when we try to prevent or avoid quality problems. Now these costs, they are associated with the design, implementation and maintenance of the quality management system. These costs, they are incurred at the planning stage, that is before the actual operation. Now in this case we build the specifications for incoming materials, processes, finished products and services. We take into account quality planning here. We create plans for quality, reliability, operations, production and inspection. We start the systematic activities of quality assurance here so that we can get the desired quality in products. We also train our employees, and we develop our employees, prepare them, and maintain the programs. Costs of quality. Costs of poor quality. Costs of finding and correcting defective work. Costs of poor quality can be categorized into cost of non-conformities, cost of inefficient processes, cost of lost opportunities for sales revenue. Objectives for evaluating quality and costs. To quantify the size of the quality problem, to let an impact on upper management. Identify major opportunities for reduction in cost of poor quality. Identify opportunities for reducing customer dissatisfaction and associated threats to sales revenues. Provide a means of measuring the result of quality improvement activities. Align quality goals with organization goals. Prevention costs. Prevention costs are incurred to prevent or avoid quality problems. These costs are associated with the design, implementation, and maintenance of the quality management system. They are planned and incurred before actual operation. Product or service requirements. Establishment of specifications for incoming materials, processes, finished products and services. Quality planning, creation of plans for quality, reliability, operations, production and inspection. quality assurance, creation and maintenance of the quality system, training, development, preparation and maintenance of programs. The second kind of costs of quality can be defined as appraisal costs. The appraisal costs are spent by an organization in measuring and monitoring all the activities that relate to quality. So these costs they involve when we evaluate the purchased materials, processes, products and services so that they are as per the specifications given. So these appraisal costs could include verification, that is when we check the incoming material, when we check the process setup and the products against the agreed specifications. Quality audits also incur one of the appraisal costs wherein we try to confirm that the quality system is functioning correctly. The other kind of appraisal costs are supplier rating, where there is assessment and approval of suppliers and products and services. So the costs that we incur in the supplier rating will also constitute as appraisal costs. Appraisal costs. Appraisal costs are associated with measuring and monitoring activities related to quality. These costs are associated with the suppliers and customers' evaluation of purchased materials, processes, products and services to ensure that they conform to specifications. They could include verification, checking of incoming material, process setup and products against agreed specifications. Quality audits, confirmation that the quality system is functioning correctly. Supplier rating, assessment and approval of suppliers of products and services. The third kind of costs are internal failure costs. Now, internal failure costs are the ones that are incurred to rectify before the products are delivered to the customers. When the products they fail to reach the designed quality standards and before delivering to the customer they are found at the end of the manufacturing unit only, that is known as internal failure costs. Now these costs can include waste, that is when we perform any kind of unnecessary work or we hold stock such as a result of errors, poor organization or because of poor communication, we incur internal failure costs. Another kind of internal failure costs is termed as scrap. Now, scrap are the defective products or materials that cannot be repaired, they cannot be used also, and that cannot be sold. Rework or rectification is another kind of internal failure cost where we correct the defective material or errors. Failure analysis, the activities that are required so that we can establish the causes of internal product or service failure will constitute failure analysis and will be a part of internal failure costs. The next kind of costs are external failure costs. External failure costs. External failure costs are the ones where the problems or the defects are found or discovered by the customer. These products are the ones which fail to achieve the designed quality standards and they are not detected until and unless they are sold to the customer. So these kind of costs include repairs and servicing. That is, the return products when they are repaired and they are serviced that constitute external failure costs. Warranty claims, the failed products that are replaced or services that are reperformed under a guarantee will constitute the external failure costs. Whatever the costs that associate with the handling of a customer complaint will also come under external failure costs. Returns, handling and investigation of rejected or recalled products including the transport costs will constitute external failure costs. Internal failure costs. Internal failure costs are incurred to remedy defects discovered before the product or service is delivered to the customer. These costs occur when the results of work fail to reach design quality standards and are detected before they are transferred to the customer. They could include waste, performance of unnecessary work or holding of stock as a result of errors, poor organization or communication. Scrap. Defective product or material that cannot be repaired, used or sold. Rework or rectification, correction of defective material or errors. Failure analysis, activity required to establish the causes of internal product or service failure. External failure cause. External failure cause are incurred to remedy defects discovered by customers. These causes occur when products or services that fail to reach design quality standards are not detected until after transfer to the customer. They could include repairs and servicing of both returned products and those in the field. Warranty claims, failed products that are replaced or services that are re-performed under a guarantee. Complaints, all work and costs associated with handling and servicing customers' complaints. Returns, handling and investigation of rejected or recalled products, including transport costs. Quality maturity grid. The quality management maturity grid QMMG is an organizational maturity matrix conceived by Philip B. Crosby, first published in his book Quality is Free in 1979. The QMMG is used by a business or organization as a benchmark of how mature their processes are and how well they are embedded in their culture with respect to service or product quality management. The quality management maturity grid describes 5 maturity levels through which an organization or business will go through. Uncertainty stage 1, awakening stage 2, enlightenment stage 3, wisdom stage 4, certainty stage 5. Stage 1, uncertainty. The management understanding and attitude during this stage is no comprehension of quality as a management tool. Tend to blame quality department for quality problems. Quality organization status for stage 1. Quality is hidden in manufacturing or engineering departments. Inspection probably not part of the organization. Emphasis is on appraisal and sorting. Problem handling at stage 1. Problems are fought as they occur. No resolution, inadequate definition, lots of yelling and accusations. Cost of quality as percentage of sales at stage 1. Reported is unknown. Actual is 20%. Quality improvement actions. No organized activities. No understanding of such activities. Summary of company quality posture at stage 1 is: we don't know why we have problems with quality. Stage 2 is of awakening. Management understanding and attitude for stage 2 is recognizing that quality management may be of value but not willing to provide money or time to make it all happen. Quality organization status for stage 2. A stronger quality leader is appointed, but main emphasis is still on appraisal and moving the product. Still part of manufacturing or other. Problem handling for stage 2. Teams are set up to attack major problems. Long range solutions are not solicited. Costs of quality as percentage of sales for stage 2 reported is 3%, actual is 18%. Quality improvement actions at this stage are trying obvious, motivational, short range efforts. Summary of company quality posture. Is it absolutely necessary to always have problems with quality? Stage 3 is of enlightenment, management understanding and attitude is, while going through quality improvement program, learn more about quality management, becoming supportive and helpful. Quality organization status at stage 3. Quality department reports to top management. All appraisal is incorporated and manager has role in the management of company. Problem handling for this stage is corrective action, communication established, problems are faced openly and resolved in an orderly way. Cost of quality as a percentage of sales is reported at 8% and actual at 12%. Quality improvement actions at this stage: implementation of a multi-step program, for example, Crosby's 14 step with thorough understanding and establishment of each step. Summary of company quality posture. Through management commitment and quality improvement, we are identifying and resolving are problems. Stage 4 is of wisdom, management, understanding, and attitude is participating, understand absolutes of quality management, recognize their personal role in continuing emphasis. Quality organization status is quality manager is an officer of the company. Effective status reporting and preventive action. Involved with customer affairs and special assignments. Problem handling at this stage, problems are identified early in their development. All functions are open to suggestion and improvement. Cost of quality as percentage of sales is reported as 6.5% and actual at 8%. Quality improvement actions are continuing the multi-step program and starting other proactive, preventive product quality initiatives. Summary of company quality posture. Defect prevention is a routine part of our operation. Stage 5 is certainty. Manage quality organization status. The quality manager is on board of directors. Prevention is main concern. Quality is a thought leader. The problem handling at this stage is, except in the most usual cases, problems are prevented. The cost of quality as percentage of sales is reported at 2.5% and actual 2.5%. Quality improvement actions include quality improvement is a normal and continued activity. Summary of company quality posture is, we know why we do not have problems with quality. The grid is a simple 6 by 6 matrix that shows different stages of maturity of the company's quality management against 6 different quality management categories. Management understanding of quality, problem handling, cost of quality, etc. The lowest stage of maturity is called uncertainty. The organization is inexperienced. Quality management is a low priority and reactive, etc. Then, as quality management matures, it goes through the stages of awakening, enlightenment, wisdom, then the highest level, certainty. Each point, maturity versus category, on the grid has a brief description of how that combination appears in the company. Students, in this module we will talk about managing quality in decentralized manufacturing. Decentralized. Decentralized manufacturing means that our manufacturing is not at one place and we are taking the help of vendors or fabricators or different manufacturing units to manufacture our products. So all our manufacturing is not happening under one roof, rather it is getting manufactured by different subunits owned by vendors, fabricators or smaller manufacturers. Now what we are going to cover in this presentation is we will talk about Indian apparel manufacturing. We will talk about the few facts. For decentralized manufacturing, we will talk about the apparel industry and its few facts. Now the order quantities are reducing and becoming short day by day because of consumerism, we can say, or because of the short orders which are required because of continuous seasonal changes in terms of fashion. Now the apparel industry is labor controlled and it is not machine controlled. That goes to say we need to be very particular about what we are manufacturing as we have to take the output from labor. Apparel industry has varied raw materials because of the kind of categories of clothing. So we have men's wear, we have women's wear, we have kids wear. Because of the different categories of clothing and because of different fabrics, trims and accessories, apparel industry has to deal with varied raw material. We have seasonal products with lower shelf life. That goes to say, nowadays we have more seasons as compared to the regular seasons. We have festival season, we have holiday season, we have all kind of clothing wear which is there, which has got a lower shelf life because of the variation required by the customer. Apparel industry is largely decentralized in manufacturing because of the infrastructure, because of the utility of vendors, fabricators, and job workers for manufacturing. Buyers are also asking for in-house factories. Now, what is the role of fabricators? Fabricators, they help in giving the flexibility in manufacturing. They can do manual value addition very well. They can take low volume of complex styles, and fabricators are the backbone of many industrial regions in India. Now, when we talk about quality assurance for standard product, it is important to have a dedicated facility for a typical product so that we can plan and train our people accordingly. Processes, they need to be well planned, and the control parameters need to be in place in order to have quality assurance for standard products. We can use random sampling inspection at the end so as to assess the quality of the product. Generally, in our quality industry, in our manufacturing industry, planners are different from implementers. Now, what is the key to quality in fashion apparel manufacturing? So, we can talk about process capability here. When we try to be capable in the process of manufacturing garments, we are trying to have quality products at our end. So, we're going to study about process capability model here. In this case, the involvement and the commitment of top management is very necessary to become process capable for different process groups. Now, the process model for sewing. So, when we talk about process capability, we talk about quality inputs, that is raw materials and specifications. Raw materials and specifications that goes as inputs to a process and come out as an output. When the input of the output of one process is the input of another process. When we talk about quality input, that is raw material plus specification, so these need to be processed with the help of people who are motivated. They have the know-how or the technical knowledge to process these raw materials. They should have the required skills. They should have the training to process the raw materials and specifications, and they should have the required plant and machinery. All these factors will give us the required quality output, and that amounts to processed component or garments. So, as I said earlier, the process A, the output from process A becomes the input for process B. So, that's how the whole process chain goes. So, that goes to say that each process needs to be understood and worked upon in order to get a better end product. Now, there are three golden rules which need to be followed here, that the output of previous process becomes input to next process, as we just discussed, and there is no substandard input which can be given to any of the processes, and there should be no substandard output that should come out from any process. When we are going to work on each and every process independently, and when we are going to work on the input as well as the output from a particular process, we are going to achieve quality products. Now the discussion is average fabricator process capable? No, generally they are not, because they are smaller units. They may or may not be standardized. But yes, they can be made process capable. We need to find out the deficiency which can, or the gaps that can improve the processes, and that can be built into the product quality. If we want to devise solutions, we need to think non-traditionally, and we also need to check the quality of inputs that are given to the fabricators. Now there are some suggestions for improving the inputs. The manufacturer should try to have in-house cutting so that the cutting is standardized. The interlinings can be cut with technological equipments, let's say die or band knife. So we can have in-house fusing. We need to provide the right kind of needles, threads, etc. The graphical specifications of the local language, whatever we are using, that should be given to the operators. There should be multiple templates for pocket, collar, etc. and to set up special operation cell and enclosed transport for cut parts. Now to help achieving the process capability, the manufacturers or the factories need to provide the machine maintenance support. There should be need-based technical support and training as per the requirements. The illumination levels, they should be increased. There should be use of inverters, lights and fans. Cleanliness should be encouraged so that we can avoid the stains. Attachments to be provided, and special machines can be leased. Now the benefits of achieving process capability are: we promote knowledge workers, the people who have knowledge to perform particular processes. We are following the approach of doing right things at the very first time. Then we have reduced inspection. By making our processes right, we have inspection that is reduced. So we are more flexible, and we have minimum repairs and rejects, and we have increased productivity. Now there are some reasons for failure. The manufacturers, they do not have the clear quality policy, nor they have any commitment towards quality. The management may have a casual approach toward quality or the products, and to an extent they would like to blame others for the quality problems in their merchandise. Managing quality in decentralized manufacturing. The presentation coverage is Indian apparel manufacturing, few facts. Can quality be assured in decentralized manufacturing? Product versus process approach to quality assurance, process capability model, application of process model to apparel industry. Why do you face quality problems? We have no problems at our end, but our suppliers don't understand quality. Subcontractors are not bothered about quality and so on. We must answer following questions before going ahead. Can we afford to sit back and give excuses for our quality problems? Can quality apparel be produced by fabricators? Ultimately, who is answerable to buyers about the product quality? Apparel industry, few facts. Order quantities are reducing continually. Labor controlled, not machine controlled processes. Varied raw material, seasonal products with low shelf life. Largely decentralized manufacturing. In 1990, there were 48,000 fabricators and 1,040 manufacturer exporters. Buyers are asking for in-house factories. Role of fabricators. Flexible manufacturing capacity, good at manual value addition, accept low volume complex styles, backbone of fashion apparel exporting industry. Quality assurance for standard product. Dedicated facility for a product is must. Can plan detailed quality assurance procedures and train people in specialist jobs. Processes are well planned in advance with control parameters in place. Random sampling inspection at the end can be used to assess product quality. Planners are different from implementers. Key to quality in fashion apparel manufacturing: process capability. Without process capability, quality cannot be expected. It is the responsibility of top management to ensure the process capability of different process groups. Process model for sewing. Quality input is in terms of raw material and specifications, which are processed by motivated people through their know-how, skills, training, plant and machinery, and the quality output equals to processed component or garments. The output of process A is the input of process B. 3 golden rules. Output of previous process becomes input to next process. No substandard input to be given to any process. No process shall allow substandard output to come out. Is average fabricator process capable? No, but they can be made process capable. We need to find out the deficiency. To get the solutions, we need to think non-traditionally. Also, check the quality of inputs to fabricators. Suggestions for improving inputs. Start in-house cutting. Don't issue fabric. Cut interlining with die or band knife. Carry out in-house fusing. Provide right needles, thread, etc. Graphic specifications in local language. Multiple templates for pocket, collar, etc. Set up special operation cell. Enclosed transport for cut parts. Helping achieve process capability. Provide machine maintenance support. Need-based technical support and training by master or outside expert. Improve illumination level, use of inverters for lights and fans. Encourage cleanliness to avoid stains. Provide attachments and lease special machines. The benefits: promotes knowledge workers, right first time, reduced inspection, increased flexibility, minimum repairs and rejects, increased productivity. Reasons for failure: do not have a clear quality policy, nor do they demonstrate commitment to quality. Employees of these organizations are well aware of the chalta hai approach of the management. To the extent possible, they would like to blame others for the quality problems of their merchandise. Reasons for failure: belief that quality starts with inspection and ends with inspection. Mainly quantity driven targets for the departments. Departmental goals may not synergize with organizational goals. Have no idea about the cost of quality in their organization. Thank you.